So welcome back to the OSI 400 CPU build. Let me check the camera while I'm here. The previous video where we did a bunch of work is not going to be able to be edited and released. It is what it is. It's gone. So we're going to talk about what we did in that video here for a second and then jump in and finish this thing, at least as much of the assembly as we can. So I discovered earlier that not all the positions are socketed, and talking with Jonathan, Glitch himself, he was absolutely correct when he basically said to me, if the socket costs more than the jelly bean logic part, you don't socket it. And a lot of people have that opinion, and that was very true back in the day. He supplied high quality machine pin sockets. Totally agree with him. I could have put my own sockets in here for the background TTL, this jelly bean stuff, but I didn't. The reason these two 8T26s are socketed is they can be removed so it doesn't drive the bus. They don't really need to be here for standalone operation. And then the reason these 7403s down here are socketed is it's the easiest way to isolate the SRAM. The 2102s here from the system bus. If I was going to plug this into a backplane in a system and have memory off board, that'd be the easiest way to disable these. To just pull those guys out. They can't talk on the bus. Essentially they don't come into play. So in that previous video, we added all the decoupling caps, all the green caps. We added the bulk filtering cap here for the 5 volt. This cap here is for the -9. I've got one of the NPO capacitors in. I had a question about the NPO caps that Jonathan answered. I will share that with you here. We'll take a look at them. There's two of them that go up by the 74123. And both these have a red band on them. And I wasn't sure if that meant they were polarized or if that meant that it indicated the foil side. In vintage radios and in older electronics, it wasn't unusual for a foil capacitor to indicate the outside foil side. And that way you could connect that to the lower impedance side of the circuit, which often is ground. But what that would do is it would keep 60 hertz noise and that kind of stuff from getting injected into the capacitor. It would make the circuit quieter. It's not as really an important consideration here in this build. But, I was curious why these appeared polarized, and that was the answer. So I'm going to rotate him. The 100 picofarads points up. It looked to me like if I'd been there and about there and try not to destroy it, those leads will drop in and it'll just sit nice and flush on the board. These leads are really tiny and fragile. There he goes, just drop right in, flush him up, flex those out. And I'm happy with that positioning. Let's go ahead and solder that one up. So I was a little bit confused whether they were polarized or not, and I spent some time on Google trying to figure out if NPO capacitors are polarized or not. The NPO, of course, being highly temperature stable, and just couldn't find anything. And I know I think it's a polyester or polystyrene capacitor, foil capacitor. So I wasn't sure. So this one's got a little longer stance to it, I think, than that one does. No, it's about the same. So again, I'll rotate it so the 100 is up. I am going to put these in the same way his photo up on the Tindie site shows them. Why chance it? Shouldn't make a difference at all here in this circuit. That is this one right here. Get the leads to drop down in. He just fell directly into place. Again, I did a good job with the bending of those. I've still got components under here to be soldered. A lot of the ICs aren't fully soldered in. What caused me to stop yesterday was actually a parts question. So when I went to, solder in the 7417s, I discovered that what was in the kit were actually 7407s. And I did some research and discovered that the 7407, I'm going to go ahead and finish this joint on the capacitor here to get it attached to the pin. Like so. The 7417 versus the 7407. The schematic calls for 7417s. He supplied 7407s. The 7407 it's an open collector driver. It can tolerate a higher voltage on the pin than the 7417 can. I think it's almost double. It's like 30 versus 50 volts or something. It can withstand, on the pin. So it's a good substitution. So I was just curious why he made that substitution. So I didn't want to solder them in until I checked with him, just in case. This is, a newly kitted thing. I bought the first iteration of the kit. So I wanted to make sure there wasn't like a mistake, partly because the part numbers on these 4 chips are really hard to read. So let's go ahead and solder him up. I'm kind of out of sequence with what the manual wanted done, because I think there was supposed to be a test step here before I soldered the rest of these ICs in place that I have not performed. Lead tool, got 3 more of them here. If I can get them out of the foil, the anti-static foam, static dissipative foam, whatever you want to call it. My work surface here is static dissipative. It's not anti-static. It won't generate static on its own, and it will dissipate it if something that has a static charge on it touches it, such as me. So it'll dissipate that static away. It's got a 1 mega ohm resistor between the blue surface and earth. Here in the US, that's the round, the center prong. That is the earth side. That should be a good solid connection directly to earth. I grew up in an era when if your telephone wasn't working well, it could be a northing problem. This was a POTS, a plain old plain old telephone service. 2 wires coming into the house with an analog phone attached on the other side of them, kind of situation. And you get into issues where your phone would be really quiet or not work well, and often that would be a grounding issue. And often that ground would connect to like a water pipe in the house. That one is definitely going to need to be pushed up flush. I want to say it was my parents' place. I could be wrong. Where a few times in the summer I had to go out and there was... Did you really come loose? You did. There was a metal stake behind the house driven into the ground, and it had a large cable that came to it that was attached, and it was the ground connection, the physical earth itself. Ground is in dirt, and you'd pour some water around that connection, and that would get a better connection back to, wow, these really didn't stay in place well, a better connection back to that earth ground, and suddenly your phone would work much better. How did I get that one so out of place? Wow. So as I yammer on here about things, so that connection was important back in the day, and it actually still is. Let's go ahead and, which side did I solder him on? Get him pushed back into place. It's going to have to be done from this side. I don't know why these last 3 parts, I guess I just didn't do a good job taping them. Decided to lift up off the board. He's also not down flush. I hate it when I come across a board where one of the ICs is really crooked. I've ran into that multiple times, where somebody just didn't get the IC in flush and didn't do what I'm doing here, and that is tack a couple of pins, check the part, make sure it's flushed up. So let me check those out. Notches up, notches up, notches up, notches to the left. So those are in the correct orientation. So really it's just I need to solder up the field here. That's all the unsoldered pins. I've got pins here and here. these 3 devices, these 2 devices, the devices up the side. I've got a lot of soldering left to do that I won't do on camera just because that'll be nice and boring. As I do, you see it here, I've been putting together documentation as I come along. This has been updated to indicate which positions get sockets and the parts that go into the positions. I should now actually be able to apply power and see this oscillator running. The 555 not yet. There's one more thing to be added on the 555, and that's a 0.1 microfarad cap to ground. I'm also going to have to think about what I'm going to do for termination here. Signals down here get terminated with 470 ohms to +5 because I'm not using a backplane that provides termination. I need to do it on the board here, and that'll be from these jumpers here to this +5 rail here. So I'll be somehow putting in resistors to make that happen, and I've got out of my stock someplace resistors to do that right here. So I need 4.7K up here, and I couldn't find 4.7K in this body style, but I have a bunch of 470 ohm. I think that's 470. Hopefully that's not 400. Well, there's a way to find out. Is that 400 or actually 470? And of course that involves a meter. Ohms. It's in diode mode. Capacitance, mega ohms. 487. So it's a 470 ohm. It's just the purple looks very dark. And it's going to need to sit at a bit of an angle here so that I get a connection down here. I don't know if this point here needs to be pulled up as well. It might. I'm going to have to read, but I'm going to have to do something with these as well to build up those terminations. And I've got some 4.7K here, or those 1/2 watt that I could use. I don't know if these are absolutely vintage, but we'll tackle both these issues in a different video. So what else to discuss here? I've got a bunch of soldering to do. We can start to do some power up testing. We can look at the clocks. I've still got the RAM here, of course. It'll be one of the last things we put in. The processor, the monitor ROM, and the ACIA, asynchronous communication interface adapter. It'll do TTL level serial I/O. Jonathan's provided the parts here, or say it correctly, Glitch has provided the parts here to do level translation. A couple of transistors, and there's some spare parts in here. There's resistors and a diode there that can be used for level translation. I've also got a potentiometer to put in here as well. I will do that as the last thing. And I may go ahead and add that circuit to do level translation, but that says to me I require probably plus and minus 12 volts to be coming in. I don't know. Maybe, I don't know. We'll have to look at that when we get there. Anything else I need to worry about here? I think that covers everything I wanted to touch in this video. Like I said, I'll do the soldering off camera. And in the next video, I think we'll be tackling termination resistors. So I hope to see you in that video, and we'll talk soon.